Hi guys, here's your video on Chapter 10, Conic Sections. So the first part of your review talks about the definitions, and you do need to know the definitions for your assessment. It is matching, so just look for some keywords. So parabola is a set of all points equidistant from a fixed point and a fixed line. So you have your fixed point, that's the focus, and a fixed line is the directrix. The circle is a set of all points equidistant from a fixed point. An ellipse is a set of all points such that the sum of the distances from two fixed points is constant, and your two fixed points are the foci. And the hyperbola is a set of all points such that the difference in the distances from two fixed points is constant. And again, that's the foci. So ellipse is the sum of the distances, and hyperbola is the difference in the distances. For the next problem, we're writing equations for each of the parabolas. Now, when you're writing an equation for a parabola, you have two equations to choose from. You have x minus h, quantity squared, equals 4p, y minus k, and these are for parabolas that open up or down. Or you have y minus k squared equals 4p, x minus h, and these are for parabolas that open to the right or to the left. So for number 2a, I start by plotting my vertex. Now if you look at my graph for 2a, I'm just plotting the general vicinity of these points so I can figure out my direction. So my vertex is at 2, 1, my focus is 2, 5, so that puts my focus on top of the vertex. So your parabola always opens towards the focus. So in this case, it's opening up. And because it's opening up, I'm going to use the x minus h squared equation. I do need to figure out p. P is the distance from your vertex to your focus. So I am going from 2, 1 to 2, 5. That moves up 4 units, so p is 4. Now that I know p and my vertex, I can plug it into the equation. My vertex is h and k. So I have x minus 2 squared equals 4 times 4, which is 16 times y minus 1. For letter b, it's the same thing. I'm going to plot my vertex at negative 3, 3. My directrix is x equals 2, so that's a vertical line, so I'm going to draw a vertical dashed line. And since my directrix is on the right side of my vertex, that puts my focus over here, and your parabola always opens towards the focus, so in this case it's opening to the left. To figure out what p is, I'm going to count my distance from my x of 2 to an x of negative 3, that's 5 units, and since my parabola is opening to the left, I need to make p negative, so that becomes a negative 5. Since it is opening to the left, I'm going to use this equation, y minus k squared, and plug in those values. So I have y minus 3 squared equals negative 20, x plus 3. Now if I give you the focus and the directrix, we need to find p, and that's going to be half of the distance from the focus and the directrix, because that entire distance across is 2 times p, and p is the distance from your vertex to your focus and your vertex to your directrix. So I need to cut that distance in half. So going from a y of 1 to a y of 9 is 8 units. Divide that by 2, so p is 4. This one is opening up, because I open towards the focus. And from here I need to find my vertex, because your vertex is hk, not your focus. So I need to go 4 units away from 4, 9, which puts me at 4, 5. So now that I know my vertex, which is my hk, and I have p, I can go ahead and write the equation. And then letter d is the same thing, so I have negative 7, negative 4 for my focus. Directrix is x equals 3, so that's a vertical line. So this entire distance across is going from an x of negative 7 to an x of 3, so that's 10 units. I'm going to cut that in half, and so that's 5. So my vertex is 5 units away from both my focus and my directrix. And since my parabola is opening to the left, I'm going to make the 5 negative. And then once I have that, I can write the equation for that parabola. For ellipses, there's a couple things you need to pay attention to with ellipses. You have to pay attention to the direction of your major axis. You have to find the center if it's not already given to you, and you also need to know what A and B are, because that's what goes in the equation for the ellipse. So I have the center has coordinates 4, 1. Major axis is parallel to the x-axis. So if it's parallel to the x-axis, that means you have a horizontal major axis, since your x-axis is horizontal. The entire length across is 18 units, so if I cut that in half, that's what A is, so A is 9. The minor axis has a length of 4 units, because the entire length, the minor axis has a length of 8 units, so that's the entire length, so B is going to be 4. Now with the ellipses, A squared is always your bigger number and B squared is always your smaller number. So I'm going to go ahead and put my center in my numerators, so that's where the x minus 4 squared comes from, plus, and then y minus 1 equals 1. And then from here, A squared is underneath the x because I have a horizontal major axis, and then B squared is underneath the y. So I have x minus 4 squared plus over 81 plus y minus 1 squared over 16 equals 1. I'm going to go ahead and erase those marks because it looks a little messy. There we go. For letter B, I'm giving you the vertices and the endpoints of the minor axis. So let's look at the vertices. And for the vertices, I need to find the center. So if I look at my vertices, it's my x-coordinates that are different. And I'm going from -9 to +7. So that entire distance across is 16 units. So I need to cut that in half, and that's what my A is. So that's 8. So I need to go 8 units away from both of those, and that puts my center at -1, -2. So I have x plus 1 squared plus y plus 2 squared equals 1. Now for the denominators, again, I need to figure out what type of major axis I have. So again, if I look at my vertices, my x-coordinates are different, which means I have a horizontal major axis since your x-axis is horizontal. So that means A squared is going to go underneath the x and B squared is underneath the y. I forgot to even explain where the B came from. So B is the distance from your center to one of the endpoints of your minor axis. So if I'm going from -1, -2 to -1, 0, that's 2 units. So B is 2. Alright, letter C, I'm giving you the foci and the endpoints of the minor. So if I look at my foci, I can figure out where my center is because it's right in the middle of those 2 points. So -5, 0 and 5, 0. The center is at the origin, 0, 0. And C is the distance from your center to a focus. So going from 0, 0 to -5, 0 is 5 units, so C is 5. The other piece of information that I give you is the endpoints of the minor axis. So that corresponds to B. So I'm going from 0, 0 to 0, 7, which is 7 units, so B is 7. You do have a formula for the foci. It's A squared, or C squared. Let me write that down. C squared equals A squared minus B squared for the ellipse. So C is 25, A squared we don't know, but B is 7, so B squared is 49. And that's where this comes from. So I can solve for A squared is 74. Now I do still need to figure out what kind of major axis I have. This one is a horizontal major axis because your foci actually lie on the major axis just like your major axis endpoints. And since my x's are different, that makes it a horizontal major axis. All of these have been horizontal so far. Oh, letter D has a vertical major axis. So letter D is the same thing as letter C. I'm giving you the foci, so if I look at my foci, I can find the middle of those 2 points. That's 0, 0 for my center. And my y coordinates are different. That's why I have a vertical major axis. A is the distance from your center to one of your vertices, so that's 9 units. C is the distance from your center to one of your foci, and that is the square root of 31. And I can plug that into the formula for the foci, and then that gives me B squared equals 25, and B squared equals 50. I don't know why I said 25. So B squared equals 50, and since I have a vertical major axis, my bigger number is going to go underneath the y. So A squared is underneath the y, B squared is underneath the x. Alright, hyperbolas. So there's 2 scenarios for hyperbolas. I can give you the vertices and the length of the conjugate axis, or I can give you the vertices and your foci. Now, since there's only 2 scenarios, I'm only going to talk about 2 of these problems. So I'm just going to talk about A and D. because B and C are going to be the same as the other two. So I have a vertex at negative 2, 4, and my other vertex is 8, 4. So if I look at those, my x coordinates are different, going from negative 2 to 8. That's 10 units across. Cut that in half, and that's what A is. And since my x coordinates are different, that means my hyperbolas are opening to the right and to the left. So I need to go 5 units away from negative 2 and negative 8, and that is at positive 3. So my center is 3, 4. Now, since my hyperbolas are opening to the left and to the right, that means x is going to come first. So I have x minus 3 squared minus, because your equations for hyperbolas have the minus, y minus 4 squared equals 1. Now with hyperbolas, a squared is always first, and b squared is always second. So a was 5, so a squared is 25. B is 6, so b squared is 36. So I have 25 underneath my x and 36 underneath my y. For letter D, again, I'm going to start by finding my center. If I look at my vertices, my y coordinates are different, so that means my hyperbolas are opening up and down. I need to go from 7 to 1. That's 6 units, so I'm going to cut that in half, and that's what A is. So A is 3. So I need to go 3 units away from both of these points, so that puts me at negative 2, 4 for my center. And since I have my foci, I can find C, so going from negative 2, 4 to negative 2, 10, that puts C at 6. I can use the formula for the foci to solve for b squared, and you get b squared is 27. And since my hyperbolas are opening up and down, that means y is going to come first. So I have y minus 4 squared over 9 minus x plus 2 squared equals 1. Alright, now determining what kind of conic section you have based off of the equation, you're just going to be looking at your x squares and your y squares. So I'm going to start by circling all my x squares and y squares. And what I'm doing is I'm comparing them. So if you look at letter A, I only have a y squared, so that makes it a parabola. So if you only have an x squared or only have a y squared, that's a parabola. For letter B, I have 7x squared and 2y squared. So my x squares and y squares have the same sign, so that makes it an ellipse. And then for hyperbolas, my x squares and my y squares have opposite signs, so one's positive and one's negative, so that's why C is a hyperbola. And for a circle, your x squares and y squares have the same coefficient, so the same number in the front. So 8x squared and 8y squared. That's why D is a circle. Alright, for the graph. So if I look at this, my y is being squared, so that means my parabola is going to open to the left or to the right. I need to start by finding P. So I'm going to take the number that's in front of my parentheses, so negative 12, and that is equal to 4P. So P is negative 3. And since P is negative, that means the parabola is opening to the left. For my vertex, I'm going to take my x coordinate for my x parenthesis, y coordinate for my y parenthesis, but just make sure you take the opposite. So my vertex is at 1, 2. So I can go ahead and plot my vertex at 1, 2. And I'm going to move P units in the direction, so P units to the left to figure out where my focus is. So going 3 units to the left, and my focus is at negative 2, 2. Also, since it's opening to the left, I'm changing my x coordinate, and I can take 1 plus negative 3, and that's where that negative 2 comes from. For my directrix, I'm going to go in the opposite direction 3 units, and then I'm going to draw my vertical dashed line. And it crosses the x-axis at 4, so directrix is x equals 4. And then for the width of your parabola, you're going to use something called the lattice rectum, and the entire length of your lattice rectum is 12, because it comes from the number in front of your parenthesis. So I'm going to cut that in half. So from my focus, I'm going to go up 6 and down 6, and then I can go ahead and draw my parabola. Alright, what is this? This is an ellipse. So for my ellipse, I know it's an ellipse because I'm adding in between, by the way. For my ellipse, a squared is always your bigger number, b squared is always your smaller number. And since my bigger number is underneath the y, that means I have a vertical major axis. So since a squared is 49, a is 7, b squared is 16, so b is 4. My center is at 2, -3, because I'm getting that from these two parentheses. For my vertices, what I'm going to do, since I have a vertical major axis, I'm going to change the y-coordinate of my center, and I'm going to add and subtract a from that number. So if I take -3 minus 7, that gives you -10. If I take -3 plus 7, that gives you 4. So I have a vertex at 2, -10, and 2, 4. Alright, so I can go ahead and plot my center, 2, -3. I have a vertex at 2, 4, and 2, -10. B we're going to use to go in the opposite direction from my center, so B is 4, so I'm going to go 4 units to the right, 4 units to the left. And then I can go ahead and draw the ellipse. Now the two other points in here, those represent your foci, but we'll get to that in just a second. So the length of your major axis is the length of the longer side of your ellipse. So this entire length is 14 units. Minor axis is your shorter side, so this entire length is 8 units. Now to find your foci, you have a formula for the foci, and it's c squared equals a squared minus b squared. So c squared equals 49 minus 16. So c squared equals, what is 49 minus 16? 33. And I'm going to take the square root of 33, which gives me this 5.7. So just like with your vertices, where you added and subtracted from your y-coordinate, you're going to do the same thing, except now you're going to use c. So I'm going to take -3 plus 5.7, that gives me the 2.7. -3 minus 5.7 gives me the -8.7. And then I can go ahead and plot both of those, and your graph is complete. Alright, last thing, graphing a hyperbola. So your equation is not in standard form, so we're going to have to deal with that first. Since my y squared is positive, I'm going to rearrange it so my y's are first. So I have 25y squared plus 50y minus 9x squared plus 72x. And I'm going to move that constant to the other side, so I'm going to add 344 to both sides. Now for my y's, I'm going to factor out a 25, so that gives me 25 y squared plus 2y plus a box. For my x's, I'm going to factor out a -9. And that leaves me with x squared minus 8x plus a box equals 344. And since I'm adding boxes on the left, I also need to add boxes on the right. So this is going to be plus 25 times my first box minus 9 times my second box. And to figure out what goes in the box, you're going to complete the square. So I'm taking half of 2 and squaring it, which is 1. Taking half of -8 and squaring it, which is 16. On the left, we're going to factor. So that gives me 25 y plus 1 squared minus 9 times x minus 4 squared equals, and that I just need to combine, so 344 plus 25 times 1 minus 9 times 16, which is 225. And the last thing I need to do is get this equal to 1, so I'm going to divide everything by 225. Alright, so 225 divided by 25 is 9. So I have y plus 1 squared over 9 minus 225 divided by 9 is 25. So x minus 4 squared over 25 equals 1. Alright, now that my equation is in the right form, we can go ahead and find all of the pieces of the hyperbola. So this one is opening up and down since my y is first. So that gives you the direction. For the center, make sure you take your x-coordinate from your x. So I have x minus 4, so my x-coordinate is going to be positive 4. Y plus 1, so my y-coordinate is going to be negative 1. So there's my center. For your vertices, you're going to use a, and with hyperbolas, a squared is always first. So a squared is 9, which makes a 3. B squared is 25, which makes B 5. So what I'm going to do, since my direction is up and down, I'm going to change the y coordinate of my center, and I'm going to add and subtract a to it to get each vertex. So negative 1 plus 3 is 2. Negative 1 minus 3 is negative 4. Alright, let's go ahead and start graphing. So I have 4, negative 1. And then my vertices, 4, 2. And 4, negative 4. B you're using for the conjugate axis, which is the other side of your box. So I'm going to go left and right 5 units from my center. And if this were an ellipse, we would just connect all of these to make it an ellipse, but it's not an ellipse, it's a hyperbola. So I'm just going to connect it and make a rectangle. Your rectangle is going to help you figure out where your asymptotes are. So for my asymptotes, I'm going to go from my center and I'm going to go through each corner of my rectangle. So that's what I'm graphing in blue. And your asymptotes will help you figure out how wide or how narrow to make your hyperbola. So now that I have my asymptotes, I can go ahead and graph the hyperbolas. I'm going to start at each vertex and extend towards the asymptote. And there is your graph. So I'm going to go ahead and find the length of the transverse axis. That's the distance from your vertices. So this length is 6 units. And conjugate axis is the other length of the box, which was 10 units. For the equation of your asymptotes, it's y minus k equals plus or minus something times x minus h. So my k comes from my center, so I have y minus negative 1, which becomes y plus 1, equals plus or minus something, and then x minus h is going to be x minus 4. Now to figure out what that something is, you're going to go from your center to the top right corner of your rectangle and figure out the rise over run. So I'm going up 1, 2, 3, and over 1, 2, 3, 4, 5. So that something in front of my parentheses is plus or minus 3/5. And this is the equation for your asymptotes. And the last thing you need to find are your foci. So we have the formula for it. For hyperbolas, it's c squared equals a squared plus b squared. So my a squared is 9. My b squared is 25. So I have c squared equals 34. Take the square root of 34, which is 5.8. I also had written down over here. So, again, since my hyperbolas are opening up and down, I'm going to change my y-coordinate of the center, and I'm going to add and subtract c from it. So negative 1 plus 5.8 gives you 4.8. Negative 1 minus 5.8 gives you negative 6.8. And last but not least, we can graph those 2 points. Here's your first focus, here's your second focus, and you are finally finished graphing the hyperbola. Alright, I hope this video helps you get prepared for this test. See you in class.